Okay, welcome back. What I want to do today is to continue with certificate in electrotechnical technology, and again sitting girls level 3. Now again here I'm doing unit 1 outcome 6 section 10 and 11. Okay, and our title here is starting of machines. Alright, and again here is our title, starting of machines. Okay, so what I want to do is to look at type of starters, where they're used, how they're used, the wiring diagrams that would apply to these starters, the application and the use of thermistors to detect overheating of motors, so forth, okay, so that we do not allow motors to run hot. Now it's very important that you keep motors at a given temperature. If they begin to get hot, they begin to generate heat, and heat in a motor is not good for you. Okay. Okay. And here, okay, just go and make sure that we can pick this up in full. Okay. Application of health and safety, again, always first thing you will see. Every stage, health and safety every time. Do not ignore it. Okay. You should have done it already in unit 301, unit 101, or unit 201, etc., etc. It depends on which course you're doing. Okay, whether it is BTEC, City and Guilds, or EAL. Okay. And here we have understand the functions of electrical machines. Okay. Now I'll come from this session. Now at the end of this session, the student should be able to identify the principles of the starting of motors. Okay. Okay. And here we're just going to have a look at review of the previous sessions. Now you will see that I've covered session 1 up to session 10 and 11 at this moment in time. This is where we are. Let me pan back a bit, make sure we can get it in full screen. Okay. Okay. Pan back. Okay. It's for you to read and to apply, and this tells you what we have done. Okay, and what I expect to be doing on forward. Okay. Okay. Now starting a three-phase motors. Okay. When a three-phase induction motor is first switched on, there is a short-term overload. Because the reason for this is that as you put the switch and make contact, there's a massive surge of current within that circuit. But you don't need to worry, because the cables would have been calibrated to take that excess load at that moment in time for a short period of time. Okay. This is because of the large amount of inrush current, and because the induced EMF has not created enough induced current to oppose the supply. There are no strict rules regarding the requirements of the starting mechanisms for three-phase motors. Now BS7671 200, now ignore this section for the moment because this would have been done in IE regulations 17, and we are now in regulations 18. Okay. Regulations 18? Yes, regs 18th edition of the regulations, and this would come from the 17th edition. So make sure that you're checking the correct regulations and it complies with the modern day regulations as they stand. Okay, this is a little bit dated, but we don't need to change this because it states here BS7671, and that is standard. That is an international criteria which you will need to comply with. Okay. Now, the main points are the starting and running of motors heats them up. The motor's control gear and cables must be capable of handling the generated heat. Motors rated above 370 watts must have some means of overload protection. Okay. Pardon me. Types of starting. There are four main types of starting used on three-phase induction motors: direct online starter, star delta starter, auto transformer starter, rotor resistance starter. Okay. Now, there's possible that there's been a couple more added to this since. So it is in your interest to do some additional research and see whether or not you can add to this list. That's down to you now to do. Make it your business to do that. Okay. And here we are. Let me just pan out to make sure we can get it in full range. Okay. Then I'll go to section it off in sections. And here we have three phase, L1, L2, L3. Okay. And again, please note that this will be the same for any new version of this due to European criteria, okay? But I will stick with L1, L2, and L3. There are two aspects to the DOL starter, okay? Supply and overload arrangements on the voltage arrangements. Now the supply is connected via a contactor magnetic switch. The overload are connected in series with the windings. Now the overload can be magnetically or thermally operated or a combination of both. Okay? But again, remember, you need to write this information out. You need then to draw out the diagrams. Do not assume you can learn it from the screen. It does not work. You are training to be engineers. Be proficient and be engineers. And here's a diagram that you need to bear in mind, and you should be looking at drawing out in full. Okay. Okay, let me just pan back. Make sure we go up and I can get it fully screen. Okay. Okay, good. Okay. These are your overloads. These are your main contacts. This is your holding contact. Now, what happens is that when you push the start button, this contact is made, and it holds, it energizes a coil, retains through one of these here contacts through the coil, and it holds the coil in place that retains the starter in its run position. Okay. And here's our thermal overloads. Now, okay, let me just pan back and I'll make sure they're now going close. This is a purely heat operated overload. The bimetallic strip bends as the heat in the wire increases. With the increase in current, now this causes a contact to open and the hold on contact of the starter has its supply removed. Therefore, when the hold on contact supply is removed, the starter will drop out, thereby isolating the motor from the supply. Okay? And this shows you just how it operates. Okay? So current, okay, current flow, fixed mounting, bimetallic strip. This will bend and it will simply click out of position, knocking this pivot out of place. Okay, support. Okay, and again, do some additional research for yourself. Okay, draw these out. See how they've done it in the electrical principles book. There's quite a few of them. Okay, and again, here you are. Okay, this is its stationary starting state. This is its activated state. Okay, starting state, activated state. You can see how the bimetallic strip has bent and knocked the switch out of place, thereby isolating the motor from the supply. Okay. Okay. Now, magnetic overloads. Adjusting cap. What happens here, this cap can be rotated, and as you screw the cap in, you can increase its speed or reduce the speed of operation. This is called a dashpot, and this is filled with oil. Okay, and what happens that as this moves through the oil, it controls the speed. The oil helps to reduce the speed so it doesn't just drop, and once it's triggered, it will disconnect your supply from the motor. Okay, so short circuit coil to tripping mechanism, etc., etc. Okay, now again, I've only given you a preview here, but make it your business to look up and find out exactly and draw the diagrams out so you understand the concepts behind it. Okay, now as the current increases, the surrounding magnetic field increases and trips the mechanism. The speed of the operation is controlled via a dashpot filled with oil. The dashpot can have the settings changed to fit the particular motor. Okay, and that's your oil filled dashpot there. Right, electronic overloads. Electronic overloads. Now, a thermistor is a thermal resistor. It has constant resistance over a certain temperature. Word thermistor. Okay. Now, and then you have you have this type of disc thermistor. Very small but very sensitive, 2.2 ohms. Now, resistance value can also be a PTC type. Oh, you have to look at what PTC is. I can't bring it to mind at the moment. So, okay, so you'll just have to look up that for yourselves and find a bit. But you'll notice that this resistance is very small, 2.2 ohms. I mean, it's very sensitive in that sense, in that case. Okay, so let's just look at this and make sure we get you into here. Okay. Okay. Now, at a certain point, the resistance that they offer increases or decreases. If the resistance increases with temperature, it is said to have positive temperature coefficient. Now we know what PTC means, positive temperature coefficient. Now, if the resistance decreases with temperature, right, then it is said to have a negative temperature coefficient, NTC. So here, this is an NTC, and the resistance decreases with temperature rise. Okay. Just making sure you can read this for yourselves, okay? Okay. Let's go back up. Okay. Pan back, okay. Okay, good. Now, thermistor controlled overload protection. Now, let's get you this diagram first, okay? Let's see this diagram into full view. Okay. Here you have your start button, right? Three phase and neutral, and your holding coil. Okay. Transformer, motor, positive temperature coefficient thermistor. And if you look back at the slide earlier, you'll see that what this means again. Okay, so bear that in mind. L1, L2, L3. Okay. Okay. Let's go back up. Sure we can get it into full play. Okay. Okay. A thermistor is fitted within the motor and is connected to a coil. it has a constant resistance over a particular temperature. When the start button is pressed, the coil, and here's the start button, the coil on the contactor and the coil on the relay coil are both energized and will remain that way until the critical temperature is reached. Now, obviously, you do not want the motor to reach that critical temperature. It's only in an emergency that you will want the motor to reach that critical temperature in an emergency situation. Okay, but besides that, that motor should run for days without any problems, okay, overheating. When this temperature is reached, the resistance of the thermistor rises. This reduces the current to the coil on the relay connected via the transformer. This would then de-energize and release the contact, breaking the supply to the operating coil, thereby breaking the supply to your motor. So these will then drop out as this is operated, okay? Make sure we can get it in full frame, okay? Just pan back, make sure we can get it in full frame, okay? And now we can get everything in frame. Okay, I think that's about it. That's good. That's good. Okay. Now, simple starter and on the voltage arrangement for DOL. That is direct online starters. Okay. And again, here you have your circuit diagram. Now, I'm not going to spend any more time talking them through to you. You can see now how these operate. Okay. Again, you're familiar with your 230-volt coil. You have a neutral, three-phase and neutral supply. Okay, so forth. Okay. Again, draw these diagrams out. Okay. Now start buttons. Okay. Now you can read this for yourself. Okay. And this diagram shows you how the start button is connected, and that you have your stop button is always connected in series with your circuit. Okay. I'll tell you the truth here now. The thing that has always amused me is the inch button. Somewhere on here, on some diagrams, you can have an inch button. It's just how that was always wired up. That always gave me a little cause for concern. I'll have to admit that. And it's quite a simple task, basically, from what I've now gathered. Okay. So I'm just going to make sure I get it back into frame. Okay. And again here, we'll simply look at hold on contacts. You have your circuit diagram here, start button, okay, hold on contacts, okay. Once you press the start button, that contactor pulls in, okay, and then it maintains the circuit through here. But when you press the stop button, that whole circuit drops out, okay. Now additional start and stop buttons, okay? All this is showing you that we can put additional stop buttons anywhere, but obviously you need to put them within sight of the machine. The idea here is to make sure that you haven't put a start button somewhere down 300 meters away and allowing somebody to start a machine that they cannot see, because when you come to work on this machine, if somebody can start it from some other distance, then it's not in your best interest. It is a danger to you. And what have we said about health and safety? Safety, safety, safety. Okay, so these are always put within sight of your machine. Okay, and the same thing for your stop buttons, easily access and easy reach. And again, draw your diagrams out, okay, always. And again, start over starters. I'm not going to don't need to go over this, okay. Direct line starters provide large starting current. Large current demand is expensive. Okay, star delta connections. Okay, the star delta starter reduces this starting current. Star delta starter connects the motor first in star and then in delta. So the motor runs in delta, but it starts in star because it uses less current to start than it would in delta. Okay. Hand operated star delta starters. Okay. Again, this is what your system would look like. That's what the starter looks like in the real world. Now they may have changed things, but I don't think they would change that much. Okay, overall. So allow for that changes in modernization, etc. Okay. And again, here you have your starter, star, and delta connections. Okay. Automatic start delta starter. Okay. Again, here you have your schematic diagrams, and draw out the schematic diagram because it shows you how each component is wired in circuit with it. And when you come to do it in the real world, okay, these will show you where your diagrams or your component parts should be. And again here we're simply showing you a difference in type of starters. Okay, again this is at level 3, so you will find that these schematic diagrams are quite useful. Okay, that is for you to look at yourself. So let me just go into, sure we can pick it up in full. Okay, all right, move across. Okay, you can read this for yourselves. Okay, don't need me to do any reading for you. Okay. Let's make sure it's all in frame. Okay, go up a little bit and just pan back and full. Okay. Okay, and it's there. Okay, good. Excuse me, sorry. Right. Okay, well, I don't need to do anything further on this. Just make sure you understand and see the principles behind it. Similar starter. Okay. Moving close to see, make sure we can get diagrams in for you. That we can get more explanations in view as well. Okay. Auto transformer starter. Okay. It tells you what it is about. Okay. Okay. And this is a rotor resistant starter. Now, this type of motor can be started against heavy load, and the control of the torque and speed is gained by extending the resistance of the rotor to an external bank of resistors. Okay. And that is your stator windings. Okay. And that is your rotor windings. So you can see that your stator windings is in delta and the rotor winding is in star. Okay. And here we have a starting of DC motors. Now again, the supply is connected through a magnetic load to the starting arm. This starting arm is part of the circuit and is spring loaded. Now again, here you can read this for yourselves, and you can see that here we have a DC supply, armature, and your field windings. Okay, and remember that DC motors are normally single phase. Okay, that's your handle. Okay, sorry, that's your handle there. Okay, and it's spring loaded, so it always comes back to the starting position. Okay, good. Let's back up a bit so I can get this into full view. Okay, so I'll pan back, get it into frame. Okay. Okay. Okay, good. Thank you. Okay. Okay, I think we can see that. Okay, good. Okay, thank you. Automatic contact starter. Okay, and again here you have this type of starter needs less maintenance and has a greater element of speed control. Sorry about that. The contacts can be controlled by build-up in induced EMF, variations in armature current and time, etc. Okay. Here again you have your motor. Okay, you have your available resistors which can be linked out accordingly. Okay. 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 I don't need to do a lot of talking now because it's now become self-explanatory, and as you're at level 3, you should now be able to draw these out and recognize the circuitry of it. Okay. Electronic starters. Okay. Soft start. Okay. Now you need to do a little bit of work for yourselves on electronic starters. There's quite a number of them, and I've also given you some work in one or two of the electrical principles lessons in regards to the videos on soft start. I've actually shown you how it's done. So look at those videos for yourselves, please. Okay, thank you. I hope you found this useful, and talk to you soon. take care and stay safe, please. Thank you. Remember, we're still in the COVID days, all right? And take care. Bye bye for now. Thank you.